Hello and welcome, future Dolphins. Congratulations on your recent admission to our school. My name is Kobe, and I'm a third-year student here at CSU Channel Islands. Today, we will be highlighting the chemistry department, and here with us today we have Dr. Blake Gillespie from the chemistry department here at CSU Channel Islands. Hello, Dr. Gillespie. How are you?
I'm great. Hi. How are you?
Um, awesome. Thank you so much for joining us today. Before we get started, please introduce yourself and tell us a little bit about the chemistry program department here.
Yeah, my name is Blake Gillespie. I'm chair of the chemistry department. I've been teaching at Cal State Channel Islands since about 2003. So I've been here quite a while and watched our program grow into something I'm very proud of.
All right, awesome. Um, so we're going to go ahead and get started with our first question here. And what are the most popular courses, minors, and options within the chemistry major?
Yeah, so I would say first that majors are probably split equally between the chemistry BS and the biochemistry option. That biochem option is a little easier to manage and navigate because there are some, even though there are more required courses, it makes it sort of easier to get through your electives requirements. There's fewer electives. The chemistry option is also great because it gives you so many electives choices to sort of explore and get to know the field. But yeah, the BA and the minor are also important choices and options. And mostly that has to do with students that want to explore maybe a double major, or they might be interested in teaching K through 12 in STEM. In terms of classes, I think one of the really hot courses right now is the upper division general education course, drug discovery and development. It's aimed at a GE audience, but it takes an in-depth look at the science and business of the pharmaceutical and biopharma industries. It's a very popular course semester after semester. Other really popular courses there's some GE courses. There's chemistry and the environment and energy and society. Those are often co-taught by chemistry and physics faculty. And I think what students like about that is that it lets them connect the big issues that they're learning about in class, say climate change or energy policy, with there's some immediate surroundings on campus. So the course is centered on student-based projects at changing campus life. And it has led to some real change, like the B Campus certification we got a couple of years ago, as well as the sustainable garden that you can see in Sierra Hall. Both of those emerged from those courses as student projects. And for the major classes, we also have some really fun, popular classes. One of those is environmental chemistry, which is a laboratory elective for majors. And it's a really great one. And during the pandemic, chemistry faculty had students building their own gas sensors at home. So hands-on work is an important part of what we do, even during these times. Another favorite is beer, wine, and spirits. And in that class, students learn some very practical analytical skills, but they're using beer and wine and other products that they make on their own in the lab too.
Wow, that's actually cool. I didn't know that. Beer, wine, and spirits. Wow, awesome. The more you know. So we're gonna go ahead into our second question, which is there any type of academic background that a student should have before deciding to enter the chemistry major?
Yeah, so the chemistry BS degrees require lots of math and physics as background. There's just no getting around that. So students that come with some introductory chemistry, calculus, or pre-calculus, they're at a slight advantage. But we also provide on campus really solid pathways for students to get that background once they arrive. There's excellent preparatory classes offered in math and physics. Some of these classes are offered during the summer, so students can get a leg up before they get here. But I would say that no student should let their academic background deter them from trying chemistry out and exploring our major. And once they begin, they'll immediately start seeing those benefits, regardless of their background.
So, what are the opportunities to participate in hands-on learning in this major? So, for example, things like undergraduate research, internships, and/or service learning.
Yeah, so I would say that experiential learning is a core part of our department's teaching and learning values. So we do build that even into introductory courses. Like I mentioned, the Chemistry and the Environment course, I believe, is a 100 level GE course that anyone can take that immediately gets students thinking about making change locally, sort of with a chemistry filter. So that continues as you get into your introductory coursework, where a hands-on component is an important part of what you're doing. But that really intensifies as you get into your upper division coursework, in which the hands-on element of a laboratory is always there. I think the what we add in chemistry is that we create a lot of those classes as research-oriented classes in themselves. So even if you can't engage in undergraduate research, you can still take an upper division lab course that's focused on research as a central defining feature. And then of course, so beyond that, we have students that participate in some internships, and we place students, those often lead directly to job opportunities, which is a really nice part of those. So sometimes we'll some fun internships are working in local breweries, or people get some experience working in the crime lab. So those are options for students as well.
And what types of jobs do graduates seek upon graduation?
Yeah, so there are so many great employment options in the local region. There's an ever-changing set of startup companies that students go work for, and as well as really established companies like Amgen or Stellar Biotechnologies. So I would say our students almost always find employment in their field upon graduation, if that's what they're after. Lots of students also go on to teach at the local K through 12 school system. Other students, as I mentioned, go to work for the county, maybe in the crime lab doing forensic science. I mentioned then an internship in local breweries that has led to employment for our students. They work as brewing chemists in local breweries. So there are lots of opportunities for students through a range of kinds of different job, but all still related to their field.
And is there ever any kind of job difference between the BS and BA?
I think the BS provides a lot broader experience. And so I guess the way I would answer that question would be to say, you'll be able to find a job with your chemistry degree, but sort of the range of experiences that you're prepared to step into might be a little broader if you have the BS degree, because you've experienced so many other electives courses and had so many other opportunities to learn other material. So it really is a matter of how you're able to present yourself on your resume in terms of the kinds of hands-on experiences that you've had. And you have more of those with a BS.
And how does your program prepare students for graduate school?
Yeah, I think about 10%, some semesters, some years more, but something like 10% of our students go on to graduate programs. Those are mostly PhD programs, although some students go on to a master's degree in chemistry first. But that number also includes students going on to medical schools and pharmacy schools. And I think there's two main ways that we prepare students. And first is obviously excellent instruction from all of those preparatory classes that I mentioned earlier. But that excellent instruction starts with preparatory introductory coursework, but goes all the way through our advanced electives. I think our faculty are really amazing at developing solid curriculum to prepare students. But second is access to undergraduate research experiences. And we have the traditional pathway for undergraduate research. We have several faculty that have really terrific research programs, research laboratories. Students get opportunities to not just do the work, but also travel to present their work at local and regional conferences and even publish their work in peer-reviewed science journals. So there's really great opportunities there. But that isn't always for everyone. So students that can't participate in undergraduate research, we still build their critical reasoning and hypothesis construction skills, how to do science, even in that intro coursework. But once you're in the upper division electives courses, many of those courses are structured as, they're called course-based research experiences, or cures. And so the course content is really built around exploring students' interests and ideas as they focus on the topic at hand. And so throughout the curriculum, we build undergraduate research as a training tool, and that students find is a very effective way to learn about what the graduate school environment is going to look like. And so in graduate school, yes, you often are going to take courses, but in chemistry, the real work is getting straight into the laboratory to get your research done. And if you've had experience doing that, as you have at all stages of your chemistry degree at Channel Islands, then you're really well prepared for what that environment is going to present to you.
Awesome, wonderful answer. So, is there any general advice that you can offer a student who is just beginning their studies at CSU CI?
Yeah. In college, you should take advantage of every opportunity that you can. You got to learn about travel opportunities, and not just learn about them, but take advantage of them. Find out about internships and find one that suits you. But remember too, that every class that you take opens a door that you didn't know was there. So you got to make yourself open to those opportunities. You got to find out about the GE offerings that are going to expand your experience as soon as you get onto campus. Learn about undergraduate research and try to get involved as early as you can and as deeply as you can. And, that in particular, I think, is the best way to learn what life is like as a chemist after you leave here. You have to engage in laboratory research in order to find out what that's really about. So I think that's what I would say to a beginning student.
Okay. And are there any clubs for students to join that are specific to chemistry?
Yeah, we have a great and active chemistry club. They're called the Free Radicals. And they engage in all kinds of projects on campus, ranging from sort of mundane selling laboratory manuals at the beginning of each semester to a bunch of other really fun activities across campus. So yes, that's the main way for students to get involved in a chemistry club is through the Free Radicals.
All right, awesome. So far we've been kind of talking about chemistry and kind of the gist of it here at CI, but I actually want to get to know you a little bit better. So what first made you interested in chemistry?
I was actually in college studying a range of different topics. I really thought I wanted to be sort of a marine biologist, but a transformation happened for me in biochemistry. So I was in my biochemistry course, and that course introduced me to the structure of living systems at an atomic scale. And once I sort of saw that life is built of these sort of elements, I really that molecular structure of biological molecules really got me excited, and I was hooked at that point and I've studied biological structure every moment of my life since then, whatever that was, the last 35 years or something.
All right, awesome. And I know you have been here quite a while. I think you said 2003, if I remember correctly.
Yeah.
So after all these years, having all this experience, all these different courses and students, at the end of the day, what is your favorite class to teach?
The favorite class I teach?
Yes.
I've really built my life hopping from new class to new class. When I first started here, I created the chemistry of the kitchen. And now kitchen chemistry classes are popular all across, higher education, but ours began long ago, back in 2006. And that one was a real favorite. It's a GE class, but it really brings science to students in a way that they can really bite into. I have developed lab electives as well that I really love. Molecular structure determination lab that I teach and has students growing protein crystals and sending those crystals off to national research laboratories for remote data collection. I think that's a really exciting sort of toolkit to provide to students. One of the classes I've developed most recently is another GE class called Science Fiction. I co-teach that with an English professor, Dr. Raquel Baker, and that's a really exciting class. It does. So a theme for me has been, how do I bring my own excitement for science and chemistry to a broad audience? How do I engage with the rest of the campus, not just with chemistry majors? That sort of has popped up frequently over the course of my time here. So science fiction is sort of the latest manifestation of that.
Okay, awesome. And before we start to wrap things up, I have one more question here. And having so much passion for chemistry in the department, what do you think really makes the chemistry department different than any other department on campus?
Undergraduate research is a big part of our campus, and I think that's in no small part because of the role chemistry has played over the last, as I said, over the last 20 years in popularizing that as a way of thinking about rounding out a student's undergraduate education. Obviously, it's goes well beyond chemistry, but I do believe what we've tried to do in chemistry is make that a central piece of as many students' experience as possible. So we have 5 faculty that engage as many students as they can in their undergraduate research projects. Many of those are very successful in leading to good publications and other opportunities for students. So I think that's a defining characteristic. I think it's also a defining characteristic that our faculty are energetic enough to try to develop these kinds of research questions directly in the curriculum as well. It takes a lot of time and a lot of effort and a lot of creativity on the part of the students and the faculty. So I guess I would say that our students are just as much responsible for the success of those experiments as the faculty are. But again, I think that engagement with developing research questions and addressing our energies to those research questions is an important part, the central part of chemistry for me.
Thank you so much, Dr. Blake Gillespie. Students, if you have any more questions about the chemistry program, please visit go.csuci.edu/academics. Bye, and we hope to see you in the fall.